This video covers section 5.8, solving equations by factoring and problem solving for math. Our goals in this section are to solve equations by factoring and then to solve some problems that can be modeled using a polynomial. Basically, we're going to be solving equations by factoring and then also doing some word problems. So far in this chapter, you've done a lot of factoring, and we promised that that would lead up to actually solving some equations. So before we move on, I'd like to review what the difference is between an equation and an expression and talk about some of the things that you can do with equations that you can't do with expressions. The big difference between an equation and an expression is that an equation has an equal sign. So it might say something like 2x plus 1 equals 3x minus 4. Expressions don't have an equal sign. They're the things that would go on either side of the equal sign, though. Something like just the 2x plus 1 or just the 3x minus 4. In order to talk about solving something, we need it to be an equation. You can't solve an expression. If I just give you 2x plus 1, there's nothing to be done with it. But if you have an equation like 2x plus 1 equals 3x minus 4, then you can solve for the values of x that make the equation true. That's what we're going to be doing in this section, using factoring of expressions to solve equations. To understand how factoring can help you solve equations, we need to get a handle on the zero factor property. So I want you to think about how you can multiply two things together and get zero. For example, I've got this equation that says 2 times x equals 0. What does that tell you about what x has to be? If you're not sure, that's okay. We can go ahead and solve this equation. 2 multiplied by some number equals 0. In order to solve this, I would divide both sides by 2, giving me x equals whatever 0 divided by 2 is. 0 divided by 2 is just 0. The big deal here is that in order to have some number times some other number and equal 0, one of those two numbers has to be 0. That's all that the zero factor property says. If you have two things being multiplied together and you get 0 out, that means that one of the two things had to be 0. This turns out to be true even if there's more than two factors, but it only works when your factored form is set equal to 0. We're going to be able to use this to solve equations when they're factored, and of course, set equal to 0. So for example, let's go ahead and solve this equation. I have an already factored thing, x plus 3 times x minus 2 equals 0. Now, if I multiply two things together and get 0, that means that one of the two things had to be 0. So either x plus 3 equals 0, or x minus 2 equals 0. This breaks down into two little equations. Now, I can solve both of those pretty easily. If x plus 3 equals 0, I subtract 3 from both sides to get x equals negative 3 as one of my answers. And if x minus 2 equals 0, I add 2 to both sides to get x equals 2 as my other answer. So what we did here was notice that if you have two things being multiplied together and they equal 0, then one of the two things has to be equal to 0. And that let us write down two new equations. Either the first factor is equal to 0, or the second factor is equal to 0. And then we were able to solve those nice little equations to get our two answers. Notice that you could always check this by plugging your answer back in, one at a time, to see what you get back out. We should get 0 if we plug either of these numbers back into the original equation. Of course, usually the polynomial isn't already factored for you. That's why you've been practicing so much factoring. So for example, we can solve this equation by first factoring this and then setting each term equal to 0. So we'll start by factoring this. I'm going to use the a times c method to try to factor this thing. A times c is 3 times negative 2, which is negative 6, and my b term here is 5. So I'm looking for things that multiply together to be negative 6, but add together to be positive 5. That means one of them will have to be negative. I'm thinking that negative 1 and positive 6 will work. Yeah, since negative 1 times 6 is negative 6, but negative 1 plus 6 is positive 5. Remember that if you're having trouble finding these two numbers, you can always make a list off to the side of all the possible factors of negative 6 to see which ones will add up to be 5. Back to the factoring. Now that I have my two numbers, I'm going to take my 3x squared plus 5x minus 2 and use these two numbers to split up the middle term, making it 3x squared minus 1x plus 6x minus 2. And I'm going to go ahead and continue writing equals 0 off to the side so that I don't forget that this is an equation that I ultimately want to get an answer to. So now I do factoring by grouping, group my first two terms together, group my last two terms together, From the first two terms, it looks like I can pull out an x. That leaves me a 3x minus 1. And from the second two terms, I can factor out a 2, which leaves me also the 3x minus 1. Because these two are the same, I can finish factoring this as 3x minus 1 multiplied by x from the first term plus 2 from the second term. Now I've got my factorization. But we're not done yet. Remember, our goal is to solve this equation. So this is the factored form, which is great, but we need to go one step farther now. Take each factor and set it equal to 0. So I'm going to write 3x minus 1 equals 0, or x plus 2 equals 0. Now I have two little equations that I can solve. For 3x minus 1 equals 0, I'll add 1 to both sides, which gives me 3x equals 1, and then divide both sides by 3, so that x is 1/3. For the x plus 2 equation, I'll subtract 2 to the other side and get x equals negative 2. Once again, remember that you can plug these answers back into the original equation to make sure that they work out correctly. Now that you've seen a couple of these problems, it's your turn to give them a try. Why don't you pause the video and then try solving each of these equations by first factoring and then setting each factor equal to 0. Go ahead and give it a try. And we're back. Let's look at these problems together. I started here with x squared minus 5x plus 6 equals 0. I factored x squared minus 5x plus 6 into x minus 2 times x minus 3. Now, since this whole thing is set equal to 0, I know that either the x minus 2 factor equals 0 or the x minus 3 factor equals 0. So I write down those two equations, and then I solve each equation, which gives me x equals 2 and x equals. For the second equation, I tried to throw you a bit of a curveball by giving you two terms that have a greatest common factor that you can factor out. So I had x squared plus 2x equals 0. I started by factoring out an x, which gave me x multiplied by x plus 2 equals 0. Now it's still true that if I have these two things being multiplied together to equal 0, one of them has to be 0. So either the x is 0 or the x plus 2 is 0. This one's really nice because just by writing down my little equation, I've written down my answer already. For the x plus 2 equals 0 part though, I need to go ahead and finish solving that to get x equals negative 2. Now, I really want to drive home the idea that in order for the zero product property to work, you have to have the equation set equal to 0 before you start trying to factor. So for example, here I have x multiplied by 5x minus 7 equals negative 2. There are actually a lot of different ways that you can multiply two things together and get negative 2. So this doesn't really tell us anything useful yet. We need to get the whole thing set equal to 0. We can do that by adding a 2 to both sides, so that I have x times 5x minus 7 plus 2 equals 0. Unfortunately, now this isn't factored. Now I don't have one thing multiplied by another thing equals 0. In order to fix that, I'm going to need to distribute this x, combine like terms, and then see if I can factor it. So let's go ahead and get started on that. I'm going to distribute this x, giving me 5x squared minus 7x plus 2 equals 0. There's no like terms to combine, so now I can try to factor this thing. Using a little bit of guess and check, I found that this factors as 5x minus 2 multiplied by x minus 1. Now we're finally back to a setup where we can use the zero product property. I have one thing being multiplied by another thing to equal 0. That means that one of the two things has to be 0. So 5x minus 2 equals 0, or x minus 1 equals 0. Then we can go ahead and solve these little equations. 5x equals 2, so x equals 2/5, and x equals 1. Again, the point of this example is really to drive home the idea that in order to use that zero factor property, your equation needs to be set equal to 0 on one side, and you need to end up with something multiplied by something else equal to 0. With that, we can go ahead and write a list of steps for solving polynomial equations. Your first step is to write the equation in standard form with one side equal to 0. That means you're going to have one side equal to 0, and the other side will have everything multiplied out and all like terms combined already. Then you'll factor the polynomial as much as you can. Then you set each factor that has a variable equal to 0, solve those little equations, and then you should always check your solutions back in the original equation. Let's do some examples. I'm going to start with this one. X cubed plus 7x squared equals 4x plus 28. So this isn't set equal to 0 yet. So I'm going to need to start by subtracting 4x and 28 from both sides. That gives me x cubed plus 7x squared minus 4x minus 28 equals 0. Now I have a thing that has 4 terms. That suggests that I need to try factoring by grouping. So I'm going to go ahead and group my first 2 terms together and group my last 2 terms together. My first 2 terms have an x squared in common, so I'll factor the x squared out, which gives me an x plus 7 left over. My second 2 terms look like they have a negative 4 in common, so I'll factor out the negative 4, which also leaves me with an x plus 7. And now that I've got my 2 groups factored, I can pull that x plus 7 all the way out, leaving behind x squared minus 4. Now I go ahead and look at this polynomial one more time to see if I've really factored it completely, and I notice that x squared minus 4 is a difference of squares. So this can be factored just a bit more to be x plus 2, x minus 2. So now I have x plus 7 times x plus 2 times x minus 2 equals 0. I'll set each factor equal to 0 and then solve the resulting equations. So I have x plus 7 equals 0, x plus 2 equals 0, x minus 2 equals 0, which gives me x equals negative 7, x equals negative 2, or x equals positive 2. So again, what we did to solve this equation was to first move everything over to one side so that we have a polynomial set equal to 0. Then we factored the polynomial as much as we could, and then set each factor equal to 0, which gave us 3 little equations that we could solve, giving us 3 answers. Let's go ahead and do another example. Here I have 2x squared plus 5 halves x equals 3, and I want to solve for x. There are a few different things that I could do to get started on this problem. For instance, I could start by moving the 3 over to the other side to get the whole thing set equal to 0. But honestly, the first thing that I want to do is multiply everything by 2 to clear the fractions. So let's go ahead and do that first. We're going to multiply every term by 2 in order to clear the fractions. Now 2x squared multiplied by 2 is 4x squared. In the 5 halves x, when I multiply it by 2, the 2's cancel, and I'm left with plus 5x, and on the right-hand side, I'm left with a 6. And now that the fractions are out of the way, we can move on with this problem. Now I can go ahead and follow those steps for solving a polynomial equation. I want to get the 6 over to the other side so that my whole thing is set equal to 0. So I subtract 6 from both sides, giving me 4x squared plus 5x minus 6 equals 0. And now I need to factor. I'm going to go ahead and show you that a times c method again. Here I have a is 4 and c is negative 6. So a times c is negative 24. And then my b term is positive 5. So I'm looking for things that multiply to be negative 24 but add to be 5. Now, if you're looking at that and 2 numbers aren't just popping into your head, you can always go ahead and make a list off to the side of all the things that multiply together to be negative 24. I could have negative 1 and 24, but that's not going to add up to 5. I could do negative 2 and 12. I could do negative 3 and 8. And that one, actually, that looks good. 8 plus negative 3 is 5, so I'll go ahead and use negative 3 and 8 as my 2 numbers. Now I can go ahead and use those 2 numbers to uncombine my middle term, giving me 4x squared minus 3x plus 8x minus 6 equals 0. Then I group those 2 terms together at the beginning, and I group the last 2 terms together and factor by grouping. Out of the first group, it looks like I can pull a single x out, which leaves behind a 4x and a minus 3. And from the last 2 terms, it looks like I can pull a 2 out, which leaves me with a 4x and a minus 3. These match up, that's good. That means that I can pull that all the way out to give myself 4x minus 3 times x left over from the first term plus 2 left over from the second term. Now I've got it factored. Now I know it feels like we ought to be done now, but remember our goal was to solve this equation for x. So now that I have it factored, I take each factor, set it equal to 0, so 4x minus 3 equals 0, or x plus 2 equals 0, and then solve those 2 little equations. We're almost there. For 4x minus 3 equals 0, I add 3 to both sides, giving me 4x equals 3, and then divide by 4, giving me x equals 3/4. For x plus 2 equals 0, subtract 2 from both sides, and x equals -2. Now that you've seen a couple of examples, it's your turn to try a couple problems on your own. So go ahead and pause the video, try each of these problems, and when you're ready, start the video back up and we'll talk about them together. All right, are you ready to look at these problems together? This first problem was x cubed equals x squared plus 6x. So my first task was to move everything to one side so that I have some polynomial equals 0. So I subtracted x squared and 6x from both sides. That gave me x cubed minus x squared minus 6x equals 0. Now I look at this thing and see what I can do to factor it. I notice that they all have an x in common, so I start by factoring out that greatest common factor of x. That left me with x squared minus x minus 6, which can be factored further. So I went ahead and factored that to be x multiplied by x minus 3 times x plus 2. Now I have three things being multiplied together to equal 0, which means that there will be three possible answers. Either the x is 0, the x minus 3 is 0, or the x plus 2 is 0. That gave me three little equations to solve. The first one was really easy. And for the second one, I ended up with x equals 3. And then for the third one, I got x equals -2. For this second example, you also had to move something to the other side to get it set equal to 0. I had y squared plus y equals 72. So I subtracted 72 from both sides to get y squared plus y minus 72 equals 0. Then I factored this as y plus 9 multiplied by y minus 8 equals 0. That means that either the y plus 9 is 0 or the y minus 8 is 0. That gave me two little equations to solve, which resulted in y equals -9 and y equals 8. I'm going to break this video into two parts. We just finished part 1, which was all about solving equations by factoring. The next part will be about problem solving, that is, word problems. There's lots of examples that you won't want to miss.